So I'm kind of doing this for a colleague of mine, Debu Panda, who is a local. I'm not local, I'm afraid, but I certainly can answer any questions that people have, and I certainly know the material. So what I'm going to do is kind of do an overview of persistence, which is what I think this talk is supposed to be, is an overview of the persistence API. So if you have any questions as we go along, feel free to wave your arms. I might not see you, and if I don't, then ask me again near the end, and we'll be able to answer them then. I've been doing persistence for a long time. I was involved with the JPA 1.0 specification, and amongst other specifications, and co-wrote a book on JPA. So I asked people in the workshop this morning, we did a whole, I don't know what it was, 3 or 4 hours or something, on EJB3 and JPA. And so I wanted to know how many people had used JPA and EJB3. So I'm going to ask you guys the same thing. How many people here have already had some exposure or use of JPA? Okay, I don't see very well, but I think there's only about 3 or 4 hands come up. That's about right. This is, as I said, a very introductory level talk. So if you know too much about JPA, then you probably won't learn too much here. On the other hand, it certainly gives you an opportunity to ask questions about things that you may have found in the past. How many people here are using proprietary persistence APIs of some kind? That means proprietary means Hibernate or TopLink or JDO vendor. Okay. How many people here think that you'll be actually using JPA fairly soon? A few of you. And that means the rest of you think that you'll never actually use it, but you still want to know what it is. And that's also fair. However, I think that at the end of the talk, then you should also be in a position where you might actually want to use JPA anyway. We'll see. Okay, let's talk about JPA. It is an API for operating on objects. Particularly, we call these objects entities. Entities are the term that we chose for a couple of reasons. First is because it's the term that is used prominently in the database world, i.e. entity relationship. And so it is kind of the thing that you store in a database. This is what an entity is in JPA. It's a thing that you store in a database and essentially corresponds to a row in a table. That's kind of the way it always has been anyway. It's just that this is a much more formal and an appropriate term for the word, for the object that we're talking about. The second reason was because we wanted to differentiate it from entity bean, which JPA replaced as a technology. For those of you who know, how many people here were using EJB2 entity beans? A number of you. Wow. I'm sorry about that. I'll have you know that I wasn't actually part of the specification for entity beans, so although the colleague beside me at the time was, but we did actually try at the time to get Sun and others to not define entity beans as they were, but to go at a different route, to no avail at the time. So we could have saved you from that, but it didn't work out. In any way, the JPA specification was essentially a merger of the expertise and experience of a lot of the products that had been in the space for a number of years. Among them, TopLink, which had been 10 or 12 years ago, has been going ever since and developing, maturing. Hibernate, which has been around for 4 or 5 years. There's something in our theater. I think it's a squirrel. Chipmunk. Do you guys have chipmunks here? No. Do you have squirrels? Okay, then that's a squirrel. And then, JDO has been around for also 4 or 5 years. EJB, there are a few things that, kind of EJB influenced, but most of it's from the OR mapping space that this actually came from. There are a number of you that, maybe not you personally, but people that I've met at least, that have said JPA is just a repackaging of Hibernate. And as I told the people in the morning, I'll tell the people here that anybody that says that JPA is just a packaging of Hibernate is really just showing their ignorance about object relational mapping. The reason why they say that is because Hibernate is the only thing they know. If they knew anything else about object relational mapping, they would realize that JPA is a specification and a standardization of object relational mapping that has been around for over 15 years. And in fact, a lot of the things that Hibernate does, certainly Hibernate didn't invent, although maybe people became accustomed to it through Hibernate as an experience, but Hibernate certainly can't take credit for what has become known as object relational mapping. This is actually important because anybody who uses any product related to object relational mapping is going to recognize the product that they are using in JPA. So whatever you're using, you'll see it there, and you'll say, oh yeah, it came from this. And hopefully that's what you'll see, because it really did come from that. It came from all of those things. It integrates with Java EE in a very neat and tidy way. It makes it very easy to use, and it melds persistence in with the component model of EJB. It doesn't restrict it to being used with EJB, but it does have a very, very nice integration. And of course, you still can use it outside of the container on its own in a standalone Java SE environment. And we call this the Bootstrap API. The last bullet on this slide is essentially telling you that we designed JPA so that it could be pluggable, meaning that one of the greatest benefits of using JPA is that you can write your application to an API, and then if something with the implementation of that API is bothering you, or doesn't work out with your application, or isn't scaling, or whatever, is hitting a wall somewhere, then you can, if your application is written to the API and been strict about that, then you can take the implementation and rip it out and plug in a different one and try that one out without actually changing your application. Now, if you've used other features of the JPA provider that are native to that JPA implementation, then you may have a few twiddles to make. But depending on the extent of that, then you should, in theory, be able to take out that implementation and try it with others. And I've had people actually try that, and it works. So that's one of the joys of having a spec and a standard, is that you're not locked into any one vendor. And if that vendor decides to change things, or work a slightly different way, or start charging you more money for what you're doing, or whatever, then you're free to ditch it, change vendors, and your application doesn't suffer. The reference implementation of JPA 1.0 is on Glassfish. How many people here have heard or are using Glassfish? Ah, very nice. So Glassfish is actually a pretty decent server. It's a lot different from some of the other servers in the past that Sun has put out in reference implementation sense. It's an industrial strength server, and it's open source and it's free, and it works really well. I prefer it over JBoss as an open source server. I find that it's more robust and much easier to work with. But Glassfish is a reference implementation for the entire platform of Java EE 5. And as part of that reference implementation, it includes a reference implementation for JPA 1.0, which was a kind of joint partnership between Sun and Oracle. Oracle donated a part of its top link that it calls Top Link Essentials. That is a JPA implementation and provides all the functionality that JPA requires. So of course that's open source and free, and people will just automatically get it if they use Glassfish. So that's the 1.0, and what we're talking about is JPA 1.0. If we have time at the end, I'll bring up a little bit of the 2.0 features that we're working on now, and kind of where that's going. And you can ask questions as well, or submit your favorite request for something you'd want to see in the spec. So what's an entity? Well, it's an abstract or concrete Java class that you define as a user, or rather as a developer, and that you can make an entity at any time, either through annotations or XML. And the choice is yours as to which you want to use. There are no interfaces required, although occasionally people use interfaces with persistence. It's not very often that I see that. Every now and then, though, I do. So you can still use interfaces, but there's certainly not anything that's required or expected. The The way that the persistence provider or the engine accesses the state of your entities is something of a, it's kind of a strange religion actually. That people seem set on one type or another. People that grew up using Hibernate always think that property access, because that's kind of what Hibernate started out with, is the way to access state. Other people that used TopLink and JDO felt that state accessing the state directly through fields rather, is a much neater way of doing it. In the end, JPA allows both. I still think that field access is a much preferable way to doing this, and it's a much neater and direct approach to accessing state, and it's a safer approach as well because it doesn't allow or require anything in this getter-setter method field. Serializability was something that used to be around in other versions of old entity beans and things, but there is no requirement for serializability. You may have entities serializable. In fact, you will want them to be serializable if you're ever shipping that entity to the client side, which you can do. But if you basically are happy with leaving your entities on the server and only ever access them on the server, then you do not have to make them serializable. The smallest entity you can create is just a class with an annotation or perhaps an XML element that says it's an entity. And the @entity annotation is what indicates that. The XML part here would be in a persistence XML file, or sorry, it would be in a ORM.xml file, mapping file. And that indicates that you have an entity that is appropriate for being mapped to the database and for being managed by an entity manager. The second part of the minimal entity is that you have an ID, meaning that you have something in the object that maps to the primary key in the database. And this identifier, or ID for short, is marked with an annotation called @ID. The next thing is that you may or may not put getters and setters on. That's completely up to you. If you're using field access, then they're not required. Persistent identity comes in 3 flavors. The simplest kind is a simple ID that has a simple field or property and is indicated by an ID annotation. So this just means that I have a field or property that is mapped directly to a column in the database, and I will map which column it goes to through the object relational mapping annotations or XML. The second and third cases are that you have a compound primary key, and in the second case, the ID is compounded in the entity class, meaning that you have 2 fields in the entity that both contribute to being the primary key. This is similar to the way you would have done it in EJB entity beans, where you had to have multiple fields all mapping to the primary key class with fields of the same name and the same type. People still sometimes do that, so that's why that's supported. The third way is a kind of a more object-oriented approach, where you have a primary key class and you define a field of that primary key class type in your entity class. So my employee has an employee primary key class composed of the ID and the name, but instead of saying ID and name in my employee class, I just have an ID of type employee PK, and that's looked at as being an embedded ID, meaning that the employee PK class is an embeddable object which is stored as multiple parts in the database table. The next thing we'll talk about is the persistence context. The persistence context is an abstraction. And while I talk, I'm just going to try to get a laser pointer that I found somewhere, but if I haven't lost it since. Abstraction over all of the objects that exist or are managed at a given point in time. What that means is that as I operate on objects, then I'm going to find those objects in a managed state, and as I manage those objects, then I can now cause those objects to be synchronized with the database. Well, I can only find one battery, so that's not going to work very well. The idea of persistent identity comes in yet again here because, oh yeah, I forgot about the camera. Sorry about that. When you have a persistent context, the persistence context has one object with a given persistent identity and no more. So if I have an object of a given type and a given ID, then there will not be any more than one object of that type and ID in the persistence context at a time. Okay? Anything that exists in the database but is not in the persistence context, but for which there is an instance, then that is termed detached. All right? That means that I have an instance here, got a bunch of state in it. All that state is in the database. There's a row in the database table that matches the state in this entity, has the same identifier, has the same type, but this isn't in the persistence context. That means that object is detached. If it is in the persistence context, then it is attached or managed. And that's the difference. And it turns out there is actually no API on operating on the persistence context. The persistence context is operated on through a separate artifact called the entity manager. And the entity manager affects the persistence context in how you operate on it, and also on the entities that are in that persistence context. So entities may be added to the persistence context as a result of operating on the entity manager. They may also be removed from the persistence context through a few operations that are available, but that's very uncommon. So graphically, the persistence context looks like this. The application here has an entity manager instance, and the boxes are instances, and these other kind of wordy type things are references. And that points to the persistence context. Those entities exist in the persistence context. I may have references to A and B, but entity C is in the persistence context. I just don't happen to know it. I'm not pointing to it. Meanwhile, I also have D in my application, which is not in the persistence context. If that exists in the database, then that will be termed detached. Okay? So let me make one last ditch effort. Entity manager. So that's got an API for a bunch of things that you can do to affect entities and their state in the persistence context. And you can think of it as a proxy to that persistence context. There's different dimensions to an entity manager, including the transactionality of it, the life cycle of it as well, and the scope. So we won't talk about that very much, but suffice it to say now that there are different types of them, and they can be configured slightly differently depending on your application. Sometimes it's configured for you anyway, and you don't have to worry about it. In fact, most times it is. So here's the API. We have a few more calls in this, but not too many right now. The API is actually going to get a little bit bigger in JPA 2, but right now it's fairly small and simple. So hopefully it's simple to use. Let's go through some of these. The persist, remove, pretty obvious, I think. We'll show how to use them. Refresh, merge, and find. Then there's three query methods, factory methods. These create queries, which you can then execute, and then a couple of extra assorted calls, contains and flush. So the persist inserts a new entity into the database. Okay. In this case here, we're creating a customer with an ID and a name. That's the name of the method, and we pass in the information that we want. The first thing we do is create an instance of that customer. And we do that simply by doing new. Right? Once you new up an object, then it's now a candidate for being persisted. And the way you actually persist it is you call persist on it. So I call entity manager persist, and I pass this new customer of mine into that, and that will then get persisted. Now when it actually goes to the database is up to the implementation itself. Some implementations actually eagerly write out to the database as soon as you call persist, but most actually don't. Most will write out at commit time. So when you commit the transaction, regardless of whatever type of transaction it is, it's at that point that you actually probably will see the insert happening. And in this case, if this is a session bean, for example, then this will happen at the commit time at the end of the method. Now find and remove, we can kind of do together. The find just says, I want to get a managed instance back from the entity manager. And this is most closely associated with a find by primary key query. Given a class and a primary key, I can return an instance of that type with that primary key. So we see here, entity manager find, I pass in the class, I pass in the ID, and I get a customer back. I don't have to cast because this is using a generic. The generic method will return the same type as you pass in. So this will return a customer. And I can just assign it to customer. If this is not there, then I actually get a null back. So cust will be null. That just accentuates my point. If customer is null, then I may have some processing to do afterwards to check if it's null. But it's a lot easier to check if something's null than it is to do a try catch, an exception. So then I can remove, and remove just deletes it from the database. So what I've done here now is I've removed that customer after I've found it, and that will, at the end of the transaction normally, cause the delete to occur. Question?
Can you run this find query on unique keys rather than factoring, say, for example?
No. You can't run it on a unique key because the persistence provider doesn't know that it's unique. It's only guaranteed to have unique keys in primary keys. Now, you may have generated a unique index or a unique key index on that, but it doesn't know that. And there's no way right now to tell it. Was there another question I saw? Yeah.
Compare this operation with Hibernate, because Hibernate, if you, just for reflection on Entity Manager, there we have a Hibernate template. So we do the same operation like Hibernate template of find the provider class and the primary key.
Okay, that's not Hibernate, that's Spring, right? Hibernate template?
Yeah.
Okay. Okay, well that's not Hibernate, that's Spring, but okay, go ahead.
I'm talking about, whatever. Okay, so.
That's a layer that Spring adds on top of Hibernate.
All right. So if you do that stuff, it's the same, one and the same thing. So is there any performance perspective? So you would actually say, okay, JPA is performing on a better side than Spring or Hibernate or something like that?
No, I wouldn't actually say that. A simple delegation call, and that's all the template is. It just delegates to a Hibernate session in Spring. It's not really much of an overhead. I wouldn't actually say that that really introduces much of an overhead. JPA itself is going to be delegation as well, because you're going to have an entity manager, which is going to be sitting on top of the session that is either the Hibernate session or the top-link session or whatever the X or M implementation session has, and they're all almost called sessions. And that's going to be kind of the same as well, right? So you might apply the same argument to, well, is JPA going to be not as fast as using the native underlying implementation session? Okay, and again, the answer is really not that much difference, because a simple object delegation doesn't, it's like, not even microsecond type of stuff, right? I think what causes performance differences much more than that is the implementation than simply a wrapper.
I understand what you might say if you're transacting something or if you're doing some query on the data.
Yeah.
So that is something that actually
that actually affects performance, exactly.
Is this something like the JPA is doing something, because we are not looking into the implementation of the find, we are not looking at the implementation of something that actually is improving the performance in comparison to other?
Absolutely. I mean, so that's the point of JPA, is that you have a single API, but different implementations might actually implement that differently. Someone might actually go to the database, look around and do a really bizarre query that is terribly slow. Someone else might do a very fast query. Now, find is probably not a good example of having a lot of differential because it's a simple find by primary key. It's probably going to be the same on most implementations. But there are others where there'll be much more probably varied differences. And writing to the API and trying different implementations out allows you to see those differences. Yeah. So good question. Next, operations of merge. Now this merge here is a simple method, but we kind of have to explain a little bit before we go too far. Merge is intended to allow somebody to take a detached entity instance and put that into the persistence context. So specifically, let's say I've got a customer that I've modified somewhere else, outside of my application even, and it's been passed into me, even remotely. Right? You can pass these all over the place. There's nothing stopping you from passing an entity over to the client and back again. So the client's changed the customer and now wants his changes to be updated in the database. This is what merge is designed for. Merge allows you to take a detached instance, it takes the state, and moves that state into the entity manager persistence context, into a managed instance that it knows about, and can then return. And then you can start playing with that instance. Because it's managed, any of those things that you do to that instance from now on will be reflected in the database. All right, so merge is a call that allows you to integrate a detached instance state into the persistence context and make that reflected in the database. All right, we talked about those three query methods where you can say create query on the entity manager factory. There's two kinds, dynamic and static. Those are the main two categories of queries. Sometimes static ones, we call them name queries. Because you can actually give them names, and that's how you invoke them, is you invoke on the named query. The language that we use in JPA is called Java Persistence Query Language, or JPQL. For those of you who have used EJBQL, you will recognize it because it starts with EJBQL and then goes on from there. Okay, so it's a superset of EJBQL. It's introduced a lot more than EJBQL ever had. It also simplifies a few things that EJBQL had that are not really necessary. There's native query support if you need it. We discourage it, but there's always a few cases where you need to use it. Name parameters are what are used to define a variable in your JPQL query and have that variable be bound when you execute the query. And we'll show an example of that later on. You can paginate through the results of the query, and you can return all sorts of different kinds of results, ranging from full entities to partial entity bits and pieces, to complete data projections, and to non-entities altogether. And then these additional bulk update and delete operations allow you to execute statements on the database, but still define them in terms of the entity schema as opposed to the database schema. You're operating still on entity as opposed to concrete physical tables. And then there's also hints that people can add in. So every vendor has their own features, and they are offered in the form of vendor hints. So this is the query API that you get when you get a query object. And once you've gotten a query from an entity manager, then you execute these methods on the query. The most important is getResultList, which says, I want to execute a query, and I want to return the results back to me. And that's what that's doing right there. This one is assuming a single result, no more than one object is going to be returned. If more than one is, then you get an exception. Execute update is for using those bulk deletes or bulk updates. And these are for pagination. This is to bind the parameter, if you have a name parameter or even a numeric or positional parameter. And then the set hint allows you to set the vendor-specific hints, and the flush mode determines whether a flush occurs before the query executes. So let's go through dynamic queries. Dynamic queries start out with a create query method on the entity manager, and you pass in the string of the JPQL that you want to execute. So any of these methods can be used to execute the query, but the query must be created at runtime. And it would look something like this. If I wanted to find all objects of a given entity type, and I don't even know what entity, I'm just going to return a list of some entity type, I could execute this query. I say entity manager create query, select E from whatever the entity name is, and I add on the rest of the query, E. So E is just an alias for the entity. And the entity's name is actually being passed in. And then I'm only going to receive the first 100 results. And then I'm going to execute it. Okay?
You ran a query to select only 100 results. So there are supposed 200 results. So would it be doing the query at the same time and keeping the next 100 results in cache or something?
This isn't a cursor. It's just a query that says, this is how many I'm going to get. So this is not meant to kind of do cursoring unless you define some cursor yourself over that through a vendor-specific way.
So next time I'm going to come here, so where is it going to start from?
So again, right, if I create this query and execute it again, I'm going to get the same results. Unless I set the first result to be 100. You have to set, that's where the pagination comes. Where I think we have there. Set first result. And then I can page through that way. So, this just shows that if I actually passed in a string account, then this string would end up being created, select E from account E, and that's what would be executed, and then that's what would be returned. That just means select all the accounts. Now a named query uses the create named query factory method. But this case, you will have already created the query. You may have created it as an annotation, or you may have created it as XML, but it must exist. And they're global, the names of these queries are. So there's kind of a common practice is to prefix the name of the query with the entity type that you're expecting to return, just so you don't collide. Now, let's show how to use that. Let's say that in my class somewhere, I've got this query, this annotation rather, called named query, and then I define the name as sale.findByCustID. That's the name of my choosing. And then I define the query in the form of the JPQL. Select S from sales, where the customer ID is something, and I want to order it by the sales date. So all the sales for a given customer, ordered by when they bought it. That's what this query is going to do. How do I execute this query? Well, in some method, find sales by customer, I'm passing in the customer. The entity manager that I have calls create named query, and I pass in the name of the query I want to execute. That's the one I named this query with. And I also have to set the parameter because I have a named parameter here. A colon in JPQL indicates a parameter that is named. So I bind cust ID, which is the name of this parameter, to the ID of the customer passed in. And then I execute. And I'll get all the sales for that customer. Okay? So that shows you how to use a name query and how to bind a parameter. How to define it in an annotation as well as how to execute it at runtime. Okay, let's go on to object relational mapping. The key of object relational mapping is to map the object to the database. And you may also have relationships from one entity to another, which will translate into foreign keys in the database. Once again, you may be using XML or annotations, and in some cases you might even use both, in which case the XML will always override whatever the annotation is, most always. We actually divide annotations into two kind of categories. One is a logical annotation, which is more of a modeling annotation, and then a physical annotation, which means it relates or specifies something in the relational database. So it's physical to the point of the actual data holder. XML, the only time where XML is useful in addition or instead of annotations is when you want to define settings that are at the scope beyond a single entity. And that's really the only place you can do that is in XML, because there's nothing to annotate at the multi-entity level. There's no such thing as a four-entity thing, right, in your Java jar of entities. So you have to use XML for that. Now, the simplest mapping you can imagine is when you take some state, some field in your entity, and map it to a column in the database. We call that a basic mapping. You don't even need to supply the basic annotation for a basic mapping. And so that's why you'll rarely even see @basic anywhere, because the default mapping is @basic. The only reason it even exists is to mark something as lazily fetched, which is not really very common anyway, because it's not really very useful to lazily fetch a simple field of straight data. It's way more efficient to simply get the data from the database anyway if you're already there. All the types that you might think of persisting are essentially there. There's not really any limitations that I know of. You can use an @column to override whatever the default is. And one of the keys to this object relational mapping is to establish a whole set of defaults that make you only have to specify the things that are different from the default. So an example of a customer that has a bunch of simple mappings and a table mapping to customer. First thing we do is we add our annotations on. This indicates it's an entity. This is our primary key. This one I'm not putting anything on. This one I'm putting a column, this is I'm putting a lob. Well, the table that we go to is being defaulted to the table of the same name as the unqualified name of the class. Okay, by default. If I don't specify that, then that's what it's going to turn out to be. If it is not customer, if I have a pre-existing table, which you probably will, then you use an @table on here with a name equals whatever, and then that will allow you to override what the default is and specify the name of the table you need to map to. Same with ID. I'm using the default column name, which is just the name of the field. The name, again, I'm not putting anything on it, so it defaults to name. Now, credit rating, I'm actually overriding what the default is. It's not called C_rating in the database. It's actually called credit. So I have to override it with a column annotation saying, let's go to the credit column. And then photo does in fact go to the photo column, but this is a large object, and I have to make sure that the provider knows it's a large object so it can use the large object protocol in JDBC to deal with it. That's why the lob annotation is there. And so those are examples of using simple mappings and defaults and overrides. The XML is very similar to the annotations. And the idea is that you can map back and forth between XML and annotations without having to look something up. That the annotation and the XML are so similar that you should predict what each will be simply by applying the XML style to the annotations that you have. So for example, well, there's no examples here, but if I have an ID annotation, then of course the element is going to be called ID, and so on. Now I mentioned that we can also have relationship mappings, which you of course need when you're mapping object to relational databases, or objects to relational databases. And the usual 4 mappings for relationships apply. If you have a single object, then you use many-to-one or one-to-one. And if a collection, that's a one-to-many or many-to-many, depending on the cardinality on the source side. And they can be unidirectional or bidirectional. The trick is that bidirectional has a notion of an owning side and a non-owning or inverse side. The owning side is the one that has the foreign key in the table for that entity. And the inverse side is the one that doesn't have the foreign key in its table. The owning side is allowed to override that foreign key column by using a join column annotation. And in the case of a many-to-many relationship, there may be a join table as well, or instead. It includes join columns. So let's look at an example for a many-to-one mapping. We have our annotations on there. The many-to-one says a lot of sales are pointing to the customer. Remember our sales and customer model, where a customer has lots of sales, and each sale points to the customer that bought it, the thing. So the many-to-one, and in our sale table, we have a customer ID. That's a foreign key to the ID in customer, the primary key. Well, our table is just the obvious one, and our ID is the obvious one. But how come we don't have to override cust ID? Because our field is named cust. And that doesn't seem to match what our defaults are. The reason is because the defaults are different for relationships. The relationship default is the name of the attribute underscore the name of the primary key the foreign key points to. So that's where you get cust ID. This is kind of a standard practice in relational databases, that you usually kind of underscore it with the ID or with the primary key that you're pointing to. And quite often, of course, that is ID. But so that's where this comes from. You don't have to override this because that is actually the default. It's this underscore the name of the primary key that that's pointing to. The XML, again, looks similar. Again, you apply XMLisms to the many-to-one and you get hyphens instead of capitalization. The other side of the many-to-one is the one-to-many. So this is the customer that has lots of sales. So it's got a set of sales in it. We already saw this. This was our sale from our last slide. It has the foreign key in it, but the customer has a bunch of sales. It doesn't have the foreign key, right? The sale is the owner of this relationship. On the other hand, we know this. This is just defaulting stuff, pointing to a customer, and our ID points to our ID. But the sales are a one-to-many, and they don't have any information about the mapping. All they know is they're not the one doing the mapping. They're the inverse side. The owner is sale, and in fact, it's the cust attribute in sale that owns this relationship. This attribute right here. So it says, I'm mapped by that guy. So go to that, the thing that it maps to be able to put this whole thing together. And that's all the provider needs to complete the puzzle. It now knows this is a bidirectional relationship, and it knows that the foreign key is on the other side, as it should be in a one-to-many relationship, and it knows which attribute of that other table, or the other entity, is pointing to it. Any questions about the mapping part now, before we move on? Well, there's XML. XML, just again, looks the same. We have a map by attribute that says it's the cust in. So the name of the attribute in this class is sales, and the cust attribute in the sale entity, right, which the provider can determine from reflection. Yeah.
Can you go back?
Yes, I can. To that one?
No, the XML.
The XML?
Yes. So here, when you say ID being equal to ID, it represents some
So in this case, this just says the ID is ID. That ID here is the names represent the attributes in this class.
And if you want to specify some particular name to the database, how would you specify it here?
Okay, so the question, good question. So what do you do if you want to specify a column in the database? Then we go back to what we had before, where we have our simple mappings. There is a column element nested inside the basic which says column name equals that. So again, it's the same as the annotation. Where you put the annotation at column name equals, you put the XML element at column.
That holds true for the primary key as well? The same thing?
Yep. Yep. The difference is that for a many to one, I use join column instead of column. Okay? That's the only difference. Okay. Moving on to persistence in SE. So I said that you could actually use JPA in Java SE as well. In this case, we use the Bootstrap API. Everything is a local transaction. We call that an entity transaction. That really is just like a JDBC level transaction. And you can start and stop this transaction through the entity manager itself. You can get this transaction and you can begin and commit it. We didn't talk about application manager, container managed entity managers, or go into those details, or propagation, for example, but none of these things are actually available. Everything is application managed or extended in Java SE world. That just means that the persistence context associated with the entity manager is going to continue to survive until the user calls entity manager close, once they've got the entity manager. All right? So the entity transaction, it's isolated. Every entity manager has its own entity transaction. This is not a JTA transaction, this is a local transaction. Again, it's like a JDBC transaction, so it's associated with the connection. And every entity manager that you create has its own transaction inside Java SE world, so they're completely isolated from each other. In fact, you could even use a local transaction inside the container. And of course, that transaction would be also isolated from the JTA transaction. They wouldn't know about each other either. The classes that you use inside of Java SE are primarily these two that are sort of different. This main one here is the class that you use outside. That's the bootstrapping class. That's how you get a factory. Okay? So you get an entity managers through the factory that you get from this class. The only catch is you have to pass in the name of a configuration. We call that configuration the persistence unit. The persistence unit is a named thing, so you pass the name in when you create the entity manager factory. And then once you have the factory, you can start creating entity managers at will. The entity manager factory allows you to create multiple entity managers, but they're all given that same configuration that you specified when you said create the entity manager factory. So program is worth 1,000 words. Hopefully it isn't 1,000 words. But this program here it's a complete program that you can run in Java SE. You can say Java, and then the name of this program, this class, has a main method on it. It's going to take some arguments. It won't do anything, but it'll run. So the first thing you do is persistence.createAnyManagerFactory some p unit. So whatever persistence unit you have configured, you do in a persistence XML file. And I haven't shown you that because there's not a lot of time to show things, all the extras, but it's pretty simple. You just sort of say in a persistence XML file, persistence unit name equals this name. And that's all you'd have to do, in addition to a few JDBC properties to define what the database URL and driver and such is. And then you, with your factory, can create an entity manager And once you have the entity manager, you can get a transaction, begin, do all sorts of finds or queries or whatever you want in the middle, commit your transaction, and close. Now, if you're just doing queries, you don't even need a transaction, because you don't need transactions for queries. Queries can happen outside a transaction. They're just reading data. But if you want to change that data, then you would need a transaction. Okay? And I'm just being a good citizen and closing up all my resources at the end. Is there any question about this program? So you can see, I mean, there's a few things to do. This is really where you would do your own stuff. This is a little bit more complicated than what you would do in the container. In the container, this is all done for you. You would just inject an entity manager, and the entity manager would be there. Because the container is doing all this other stuff for you. It's doing the lookup, and it's going to be doing the transaction demarcation and the closing. It's handling the life cycle of the entity manager. So the container makes things much more easy on the developer, whereas in Java SE, you don't really have a container to work with to do all this for you. There are a number of implementations that exist right now for JPA. Topic Essentials is a JPA 1.0 reference implementation. That's part of Glassfish that I mentioned. Eclipse JPA, I have a couple slides about that. I'm going to talk about it in a sec. It is a reference implementation for JPA 2.0. Okay, and that's actually a major project in Eclipse. It's not associated with the ID, but it is a runtime project. So you could use that in any server or in any Java SE environment. JBoss has a product called Hibernate. Apache has OpenJPA. And SAP has something they call SAP JPA. Of the JPA containers, these are all there. They all support it. Not all of these are certified, but they all basically support JPA hosting. What I mean is that they will support injecting entity managers into an environment, such as what they offer. And you'll notice Spring 2.0 as well hosts JPA. It ships with Topic Essentials and Hibernate, and will also ship with Eclipse JPA in the next release as the reference implementation for JPA 2. It will inject entity managers into a Spring environment and allow all the things that you can do in a regular container managed environment. All the IDEs, the major IDEs support JPA development. Eclipse DALI is one that Oracle led. It's one of the, I think it's one of the more fullest feature supports available for JPA. I haven't tried some of the other ones in a while. The latest IntelliJ I haven't tried, so I don't know if it's improved. But it provides all the descriptor support and queries and all the generation stuff that you kind of need. You don't need it, but it's kind of nice to have too. Just to know about the Eclipse Link project, where you have Eclipse JPA. This is the new reference implementation for JPA 2. JPA 2 is going to be released as part of Java EE 6. That's scheduled to be released by the end of this year, if it stays on schedule. If the platform slips, then JPA will slip as well, because it's one bundle, one package. Eclipse Link is a project that is the open sourcing of all of the TopLink source, and it includes Eclipse JPA. Again, this is runtime. This is not the tooling. The tooling was the DALI that I showed you earlier in Eclipse. This is called Eclipse JPA because it's part of an Eclipse runtime project. Eclipse is now working into runtime projects. That means you can run these Eclipse technologies anywhere that you want to. And Eclipse JPA is particularly good for that. This provides not just the regular JPA implementation, but all the extras that you want and need, like coordination in a cache of all the clustering, the more mappings and everything like that, plus extra support for the Oracle database, but it supports every database, and store procedures and all the extra stuff that people like to have. But the additional big thing for Eclipse Link is that it also supports, in addition to Eclipse JPA, it has Eclipse Moxie, which is mapping those same entities to XML. So if you want to take an object, move it from the database, do some stuff with it, you can actually map it to a schema and send it off to a web service in XML. And then SDO. How many people here have heard of SDO? Not too many. How many people here have heard of SCA? A few more. Okay. Well, I have 2 minutes. I'll go through a couple of JPA 2 things. It's basically filling out the standard with a little bit more features. Some of the stuff that people asked for. Some of the vendor extensions are being standardized that weren't standardized in the first round. And we're going to try to add in expression-based queries. We're going to have some more OR mapping options. That's already done, that part. So that's certainly going to be in there. You can have collections of basic objects. So a collection of strings, that's not possible right now through the spec. You can have the order columns for ordering the list persistently, where you can reread the list and it'll be the same order as when you last read it. And that's guaranteed. The query expressions, I won't go into that because I think you know what that is. It just means that you can actually create a new expression and do a select or something like that, right? Looks like that. And then some of the property names right now, for example, if you have toplink, then you have a toplink JDBC driver. And if you're using OpenJPA, it's called connection driver name. These are different names. It'd be nice if they were all the same, some standard names. So we've standardized those names so that you can use the same property for all the vendor implementations. So those are just some of the things we're working on right now. In summary, JPA is a lightweight API. It's meant to work on lightweight objects. It's hopefully very easy to use, and I've kind of got that report already from people. People do find it pretty easy to use. There are complexities that as you dig deeper, that you can find more. But certainly on the surface, at first blush, you can pick it up and start using it, and it will work. In general, people don't have problems using trivial programs. It's got a good query language, all that stuff. So in terms of resources, 1 minute left. The RI for 1.0 is a Topic Essentials. You can get that through Glassfish. There's also tutorials and things there. So if you go to the Glassfish website, you can learn as much about the Glassfish server as well as the persistence implementation underneath. And Eclipse JPA is at the Eclipse Link project on Eclipse. If you're interested in trying that out, you can download that. If you're really interested in using it and want to maybe change something, you can be a committer on the project because it's open to anybody participating. There's a bunch of white papers on the Oracle site that I know about. And there's a couple of books. This is Debu's book, who is supposed to be here with me. He's got EJB3 in action. There's a portion in that book about JPA and persistence. And then there's mine, the Pro EJB3 Java Persistence API, which is basically exclusively on JPA. So thanks for coming. I hope if you have any questions, you can talk to me afterwards, and we can also do things through email if that's more convenient.